Hello guys, today I got in my hands interesting example. This is German World War II S-mine, jumping mine. This one is specifically S-mine 35, meaning being accepted to Armaments at 1935. It look like so pretty much all the other family of mines in Soviet Union, OZM series, basically came up from this one. So we will just take a look very briefly how it's made and what it does. So you can see that it's just a can like so. It's relatively heavy, the explosive filling, some sources saying 180 grams of TNT, other sources 450 grams of TNT. I more believe the 450 version. Anyway, when we look from top, we can see that it's basically just a metal cup with metal can inside, and that's precisely what it is. When we look from top, we have three holes. What you were supposed to do was to put three blasting caps, three detonators in each one of the holes. We will get why do that later. Then we have the central shaft. That one is used for installation of our firing devices. So either there was just lone firing device like so, for example this one being just exposed slightly on the ground. Anybody that stepped on the mine, time delay basically started before the mine actually jumped out of the ground and exploded. I believe the time delay was somewhere around 5 seconds, 6 seconds. So when you stepped on this one, basically after 6 seconds the mine jumped up, and the idea being that by then you actually left with your foot, so the mine can jump out freely. So there is entire huge series of German World War II firing devices. So one of them is just contact one like so with these three prongs. This is your safety pin. So basically after you planted it, you were supposed just to do this, remove the pin, and since then the firing device was actually activated. But also the use with entire series of push-pull or just pull fuses that basically German army had in armaments was also expected. So for that there was even adapter like so. So you can basically use three methods of initiation. So let's say that the mine would be dug down in the ground with the firing device on top like so. So it's under the ground, only this portion protruding actually. So if somebody step on it, it will jump out. Then we can have second shaft, for example, going to the tripwire. And then the third shaft can be actually command wire, for example. So we have adapters like those for them as well. Also, there was just an adapter with basically two shafts going on each side like so without the center shaft. Or you could just use the firing device alone like so. So when we go a little bit further, this one actually uses only pyrotechnical delay also for the detonators, although that one is actually very short, and we will get shortly why is that. Just so we have everything finished from the top, this one shaft is used only as technological, that's for powering the TNT inside the mine. When we undo this central nut, we can actually remove the top of the mine, like so. So in the center, you can see here is the place for the explosive. Then we have outer cylinder, and then we have the cup. So you can't really tell it now, but these two are actually two separated cups. So after initiation, the primer basically go under the mine through this central metal shaft to the black powder charge, 50 grams of black powder that are in between the outer and inner cup. That one exploding after the 5-second delay, the entire mine jumping above the ground, and at the same moment three pyrotechnical delay shafts are activated, basically burning through. Meanwhile the mine is going up. Then the fire reaching the detonators and the mine basically explodes above the ground. So here is the space for the TNT filling. And then you can see this outer space that is filled with freely laid shrapnels, like so. In the early variants, there were just very nice spheres, very consistent, let's say. In this late war example, we can see that it's just a cut up wire, some fragments of bullet cores or bullet themselves. So this is like from the end of World War II, when they were basically filling those with anything that they got their hands on. So guys, this is the target situation. The S-mine, jumping mine, is right there. Pretty much 1 meter from it are targets that will just get annihilated. 1.5 meters from it we have helmet and Kevlar, and I'm really curious how successful the Kevlar will be in stopping those shrapnels. Then we have one target here, other target there, and then we moving to our big surface targets just to see the pattern. So around 5 meters we have this huge piece of carton. Then we basically have here from the mine, right behind the Kevlar, we have one big surface, and then we have two big surfaces over there that basically should be directly in the line of the wave of shrapnels. So let's see what will happen. Of course, I placed the mine basically in position where it would explode if it functioned as it's supposed to, but of course World War II ordnance, we can't really expect all those functions to be still present. So we just simulate the height of explosion right here, putting it above the ground and exploding it in that way. So here we go, here was the mine. Although the mine was up in the air, it still left a little crater. Then we can see that from the center to the target 5 meters away and up, that was a little bit hidden behind the Kevlar. And you can see the significant damage, especially in this right part all the way down, and it's even basically torn in the middle, most likely by the pressure wave. Then we go to the targets that are approximately 20 meters away. So here we should see only effect of the separated shrapnels. So we can see it right here, here, over there. So we have, even on this distance, actually quite sizable amount of impacts. So just in this section it's around 9 impacts at a distance of roughly 20 meters. And here on second one we can see 1, 2, 3, and yeah, that's still a very good result considering the distance. Our other target, around 3 meters away from the explosion, we can see torn with overpressure and big amount of shrapnel as well. Other target approximately 10 meters away, we can see one shrapnel hitting over there, one cutting like so, but other than that actually not many shrapnel considering the distance of 10 meters. And then from the explosion up in the air, and here we can just see one shrapnel right in the middle, and the target being torn, maybe even by overpressure, although for that it's quite a big distance. Here one more hit. Interesting. And now we will take a closer look at the Kevlar. So you can see that it's torn massively, but the most important thing is that we can see numerous impacts all over it, and there is really no chance the 3A Kevlar can stand against this. So you see multiple penetrations from multiple shrapnels. Just let's try to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, something like that. So on this close distance, even the 3A Kevlar would just not save you. Here from the helmet I managed to dug out one shrapnel that looked like so that's interesting. And generally the helmet actually withstanded the explosion quite well. We can see numerous impacts, but also we can see like bulging from inside of the helmet, but it seems that no shrapnel really penetrated it, so that's interesting. Further development of S-Mine 35 is S-Mine 44, as you can tell by the name, accepted to the armament in 1944. Body of this mine have 2 centimeters less in diameter of the outer body, so by default little bit less explosive and less shrapnel. But by far the most significant change is that they moved away from the system of the 3 detonators in 3 separated shafts, and they replaced this, let's say, pyrotechnical system with mechanical one. So in this 1944 version, we have the outer cap connected by wire with the inner shell, and basically the wire pulling on a striker exactly the same like in the Soviet OZM series. So if you want to know more, check my videos about OZM 72 jumping mine. Talking briefly about production number. In 1944, they produced 3,233,000 of S-mines of both types. In 1945, they produced 193,000. So as you can see, this armament was very common. Both types were delivered in frames consisting of 3 pieces. The other components necessary for these types of mines were delivered in the separate crate. So in this box you got fuses, detonators, T-connectors, tripwires, mounting key, and there were 9 pieces from each, so basically you got 3 crates consisting of 3 mines, and then this separated box to complete those sets. The lethal radius given by the documentation, it's said to be 15 to 20 meters, and according to the results and according to the amounts of explosive, I would bet that it's actually a bit above that. It's very interesting to take a look at this old design, because this one pretty much introduced the concept of the jumping mine, and we can see that from the 44 model to our current OZM 72 jumping mine, they are pretty much the same in many aspects. So thank you very much guys for watching. If you wish to support us, you can use the PayPal link down below or become a YouTube member for extra videos.